Now let's take a look at how to integrate powers of sines and cosine. Now we have two questions to solve. We have integrating sine raised to power 5 theta d theta, and I'm integrating 4 cos raised to power 4 theta with respect to theta. Now let's lay the foundation. We know that cos squared theta plus sine squared theta is equal to 1. And therefore sine squared theta is equal to 1 minus cos squared theta. And likewise, cos squared theta is equal to 1 minus sine squared theta. Now, in the same vein, we can have another expression for cos 2 theta. Likewise, we can have another expression for sine 2 theta, or cos squared theta rather. So we can also say that cos squared theta is equal to 1 over 2 into 1 plus cos 2 theta, and sine squared theta is equals to 1 over 2 into 1 minus cos 2 theta. So with these expressions, we can be able to simplify further any question as regarding powers of sines and cosine. So let's take our first example. It says, let us integrate sine raised to power 5 theta with respect to theta. Now, we know that sine raised to power 5 theta is equal to sine theta raised to power 5. And this can be simplified further to have sine theta into sine squared theta all squared. Or rather, you can say this will be sine theta raised to power 4, and simplifying further, we have sine theta into sine squared theta squared. So, since we know that this is integral of sine theta multiplied by sine squared theta squared d theta, we can now make our substitution of sine squared theta in terms of cos 2 theta. So wherever we see sine squared theta, we'll substitute 1 over 2 into 1 minus cos 2 theta. So this will give us integral of sine theta into 1 over 2 into 1 minus cos 2 theta d theta. Now, we notice something, that if we go via this route, it might be quite impossible to solve it. However, what if we make our substitution of sine squared theta to be in terms of 1 minus cos squared theta? So this will become integral of sine theta of sine squared theta d theta is equals to integral of sine theta into 1 minus cos squared theta squared d theta. Now this is possible because when we simplify further, we will have sine theta multiplied by 1 minus 2 cos squared theta plus cos 4 theta d theta. Now let's open the brackets. We'll have sine theta minus 2 sine theta cos squared theta plus sine theta cos raised to power 4 theta. Everything is integrated with respect to theta. Now, how do we go about solving this? Remember that when we were solving integration with algebraic substitution, we can say here that we can integrate this by making a substitution of u is equals to cos theta, and likewise here making a substitution of u is equals to cos theta. Now let's spread it out. We have sine theta minus integral of 2 sine theta cos square theta. Remember we are integrating with respect to theta, plus integral of sine theta cos raised to power 4 theta d theta. Now we know that integrating sine theta d theta, we will have minus cos theta plus c. Now let's integrate 2 sine theta cos square theta d theta. Let's go with the principle of substitution. So we say let u be equals to cos theta, and if u is equals to cos theta, du d theta is equal to minus sine theta. Therefore, d theta is equals to du divided by minus sine sine theta. So with that done, we can change variables for this, and this will give us 2 integral of sine theta multiplied by u squared and du divided by minus sine theta. This is just quite similar to what we did in integration using algebraic substitution. So sine theta will nullify sine theta, and we're left with integral of minus 2 u squared du, and this will give us minus 2 u raised to power 3 over 3 plus c. Now we can substitute our u back, and this will give us minus 2 cos raised to power 3 theta divided by 3 plus c, because u is equal to cos theta. And finally, let's integrate sine theta cos 4 theta with respect to theta. Now in this case, we also say let u be equals to cos theta, such that the u d theta, like we did earlier, is equals to minus sine theta, and d theta is equals to du divided by minus sine theta. So with that done, this becomes integral of sine theta cos theta has already changed to u as u raised to power 4, and d theta is equal to du divided by minus sine theta. So simplifying this, we have minus 1 integral of u raised to power 4 du, and this gives us integrating u raised to power 4, we have u raised to power 5 over 5, remember our minus, plus c, and this is minus cos raised to power 5 theta divided by 5 plus c. Now let us now substitute our answers to this. So let's substitute them. And integrating sine theta will give us minus cos theta. So this is give us minus cos theta. Integrating 2 cos theta, integrating 2 sine theta cos square theta will give us minus 2 cos 3 theta over 3, and integrating sine theta cos raised to power 4 theta, we will have plus minus cos raised to power 5 theta divided by 5, and everything we have a single constant of integration plus c. Now this therefore is equal to cos theta minus cos theta plus 2 cos 3 theta over theta minus cos raised to power 5 theta divided by 5 plus c. Now, we can come to a conclusion on how to integrate powers of sine. Let's come to that conclusion. But before then, let's try to solve cos raised to power 4 theta let's come to the conclusion first. The conclusion being that in general, that when we integrate cos n theta sine theta d theta, you will have minus cos n plus 1 theta divided by n plus 1 plus c. And when we integrate sine n theta cos theta d theta, we will have sine n plus 1 theta divided by n plus 1 plus c. Now let's take a look at this. In this question, we are asked to integrate, we needed to integrate sine theta cos raised to power 4 theta, theta d theta. And if you compare it with this, that means it's similar to this. So our n is equals to 4, as we have here. And our answer was minus cos 5 theta over 5 plus c. And it is similar to this principle. And the same thing applies for this, where n in this case was 2. No, we are still applying this principle. So this is the principle we'll be applying when integrating powers of sine and powers of cos. Let's take another question. Let's integrate sine square x cos 3x dx. Now, we know that cos 3x dx, cos 3x raised to power 3x can be written as cos square x multiplied by cos x. Therefore, we can rewrite this to give us a sine square x into cos square x multiplied again by cos x dx. Now we know that cos square x is equal to 1 minus sine square x. Now this can also be written out for as sine square x multiplied by 1 minus sine square x, then multiplied by cos x with respect to x. Therefore, we can open the bracket. So opening the bracket, we'll have integral of sine square x cos x minus sine raised to power 4x cos x dx. Now, instead of us going through substitution, okay, we just apply the principle that we have learned here. Okay, so let's apply the principle of integrating sine n theta cos theta d theta, and this will give us sine n plus 1 theta divided by n plus 1 plus c. Now in this case, we have two forms. We have sine square x cos x dx minus integral of sine 4x cos x dx. Now we notice that our variable here is x, and we can therefore change our variable here to x. So let's begin with integrating sine square x cos x dx. Now in this case, we realize that our n is equals to what? 2. And if our n is equals to 2, then our answer will just be sine 2 plus 1 x divided by 2 plus 1 plus c, and this will give us sine raised to power 3x over 3 plus c. You can see how easy it is instead of going through substitution method. Now let's do the second one, as we have sine raised to power 4x plus x dx. And let's apply the same principle. And in this case, our n is equals to what? 4. And this will give us sine 4 plus 1 x divided by 4 plus 1 plus c, which will give us sine raised to power 5x over 5 plus c. Now we can now further simplify this by substituting our answers, because we know that integrating sine square x cos x dx will give us sine raised to power 3x over 3 plus c. So this will give us sine raised to power 3x over 3 minus integrating sine 4x cos x dx, which was what we solved here, will give us sine raised to power 5x over 5 plus c. So as we conclude this video, let us recall the two ways of integrating the powers of sine. So we know that when we integrate cos n theta sine theta d theta, we will have minus cos n plus 1 theta divided by n plus 1 plus c. And when we integrate sine n theta cos theta with respect to theta, we would have sine n plus 1 theta divided by n plus 1 plus c. In our next video, we'll be taking a look at the integration of cos raised to power 4 theta and using another format of integration of powers of sines and cosine.